The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope you all are doing good in your house, and almost we have completed 3 chapters. So what I would say is, time and tide wait for none. So as the chapters are moving, make sure that you do your work systematically, right? That there is no lagging of your revision work. That is most important. Make sure that you follow that. Okay, children. So now we are getting into a new chapter, that is our 4th chapter. Before that, let us do a small recap of the 3rd chapter. The 3rd chapter was reactivity series and electrochemistry, right? In that we were studying about reactivity series. What are reactivity series? These are the metals which are arranged in the decreasing order of their reactivity, right? From that we came to know that the more reactive metal will be displacing the less reactive metal. From there on, based upon that reactivity series, we also studied about a name reaction which we call it as displacement reaction. What are displacement reaction? In a displacement reaction, a higher reactivity metal will displace a less reactivity metal, where oxidation and reduction takes place simultaneously. So we also call those reaction as redox reaction, and we always make sure that the more reactive metal will always undergo oxidation and the less reactive metal will always undergo reduction. That is what we learnt initially with the displacement reaction. Then we started with galvanic cell. In galvanic cell, what did we do? We took 2 separate beakers, we immersed the metal rods in that respective metal solutions, and we were connecting to the external circuit. We added a salt bridge to maintain the neutrality, and we know anode is negative, cathode is positive, and oxidation always takes place at anode, reduction takes place at cathode. So as you pass electricity, we know what is happening here. Electricity will convert the energy into chemical energy, that is chemical reactions will be generated inside in the form of redox reaction, where we know the more reactive metal will be losing electrons at the anode and the less reactive metal will be deposited at the cathode. Such a cell we call it as a galvanic cell. After learning galvanic cell, this is very important, children, because galvanic cell comes in 4 marks question. Galvanic cell, electrolytic cell together. When I say no, this separately comes for 4 marks and this comes for 4 marks. So very important in exam point of view. You may not be given the same metals, but you should know the reactivity series, or else they may be giving in bracket, right? Iron greater than copper, and they will give you what are the materials required. So you should be knowing, since iron is reactive, more reactive than copper, iron will be placed at anode, copper will be placed at cathode. So this is what is our understanding about reactivity series. Definitely this hint will be given to you in the bracket. Once after galvanic cell, we learnt about electrolytic cell. In electrolytic cell, we learnt that chemical energy will be used, or chemical reactions will be used to produce electricity or to generate electrical energy. There we studied that in one beaker we had the electrolyte, we immersed two electrodes, anode and cathode, but here anode is positive and cathode is negative, but same process takes place at anode and cathode. So children, remember, anode oxidation, cathode reduction, there is no change in that. So once after electrolytic cell, we were learning in that aqueous sodium chloride and molten sodium chloride, and the reactions were little different because in molten sodium chloride, sodium and chlorine undergoes oxidation and reduction, but in aqueous, that is solution of sodium chloride, hydrogen will be liberated instead of sodium. So that you should be remembering without forgetting. Okay, so those equations are very important for you. In the last we learnt about electroplating, that is covering an active metal into another metal, right, through the process of electricity. So that also we learnt in this chapter. So as of this chapter is very important, and you have so many questions coming in exam point of view. So definitely 4 marks questions you can expect from galvanic and electrolytic cell. Now we will get into the next chapter, production of metals. We are going to start with a new topic, production of metals. Though we don't involve in the production of metals, we use metals on a daily basis, right, for cooking or for any other purposes, any daily houseware particles, or when you go for industries or any commercial basis, you see metals are being used everywhere, right. Now metals can be seen in combined state elements, especially when they are more reactive, they are found in the combined state, or if they do not react at all, they remain in their native state, or you can call it as free state, means they do not react at all, they are very stable. Now what is a mineral? You have been hearing this word minerals, vitamins and minerals. You know children, minerals are very important for our body growth. Now metallic compounds in earth crust are called as minerals. What is earth's crust? When you dig out the earth mine, you get some elements or metal compounds. Those are called as minerals. What should be a characteristic feature of a good mineral? Or what are the properties required? Say I want this iron, or I want gold, or I want silver. What should be the characteristic feature of that? Abundance means it should be available in enough quantity, it should be available in large amount of quantity, not in very scarce quantity. Easily and cheaply separable. When I get something, I do not get it in its pure form. So I need to refine it, I need to remove the impurities, and I must get it in the pure form. But that process should be easy and cheap. High metal content. When I get something, it may have other impurities, other metals also, but the metal which I want from that mineral should be having a high metal content. A good amount, that is a good percentage of metal content should be there in that. From that we get something which we call it as an ore. What is an ore? A mineral from which a metal is economically, easily and quickly extracted. What is extracting? You extract tea leaves, right? You extract juice. When you squeeze lemon, you extract the juice through the filtrate. Extracting means something that you are refining, getting pure out of it. That is called as extraction. So a mineral from which a metal is economically, easily and quickly extracted is called as an ore. If you take children your textbook, you can refer page number 63. Okay, they have given a table 4.1. You can see in the first column metals are written, the second column ores are written, and in the third one chemical formula is there, right. Now if you see aluminium, bauxite, the formula is given there, Al2O3.2H2O. For iron you have two ores, hematite and magnetite. For copper you have copper pyrite and cuprite. For zinc it's zinc blende and calamine. Now why some metal is given, some ores are given. Now when I say bauxite, bauxite is having maximum content of aluminium in it. There will be different type of ores in which aluminium will be present, but bauxite is having the highest content of aluminium, so that is called as a major ore of aluminium. Similarly for iron you have hematite and magnetite. Now there are three questions given. You can now write, take the pencil with you and start writing. Which metal's ore is calamine? You can see children, ore name is given there. Tell me which is calamine. Yes, you are right. It is zinc. And what is the formula? ZnCO3. Zinc carbonate is actually calamine. Next, which is the ore of aluminium? Which is the ore of aluminium? You tell me the name. It is bauxite. Good. Now, which metals have sulfide ores? Lakshmi, can you tell me? Sulfide ore means where you can see sulfur S symbol present in the ore. Yes, it is in copper pyrite and in zinc blend ZnS. So, these two ores have got sulfide in it. Right, now you understood children. So, these are the metals. You should, this table is very important. It will come definitely in 1 mark question. So, you should be knowing when the metal is given, should know the corresponding ore and also the chemical formula. Right. Now, we are getting into the most interesting part of our production of metals, which we call it as metallurgy. So, before talking about metallurgy, you will see a small video on the occurrence of metals. Then we will get into metallurgy.
Occur in free states and bind states both. Metals such as gold and platinum, which are not reactive, or metals like silver, which are chemically less reactive, occur in free states. Most other metals exist in combined states in combination with other elements. They are found in nature in the form of minerals. Minerals are compounds of metals mixed with certain unwanted materials, mostly in the forms of sand and earthy impurities. These impurities are called gangue. Minerals from which metals can be extracted economically are called ores. An ore contains a high percentage of metal. Magnetite and olivine are examples of minerals which contain iron. However, concentration of iron in magnetite is higher as compared to olivine. In addition, it is more economical to extract iron from magnetite than from olivine. So, magnetite is an ore of iron, whereas olivine is a mineral of iron. In other words, all ores are minerals, but not all minerals are ores. The process of extracting metals from their ores is called metallurgy. Ores can be of various types based on the elements with which metals combine, such as oxide ores, sulfide ores, carbonate ores, and so on. Let us see ores of some useful metals. Common ores of iron are hematite, magnetite, iron pyrite, and siderite. Aluminium can be extracted from bauxite, cryolite, and corundum. Zinc can be extracted from zinc blende, zincite, and calamine. Copper can be extracted from cuprite, copper glance, and malachite. Calcium can be extracted from limestone, gypsum, and fluorspar. Silver can be extracted from argentite, and horn silver. Lead can be extracted from galena, mercury from cinnabar, potassium from carnallite, and sodium from rock salt. Let's summarize what we have learned about the occurrence of metals.
I hope you saw the video how the metals occur in the earth's crust. So now we are going to start with metallurgy. What is metallurgy? The process of separation of pure metal from its ore. What is an ore? Ore is something which has got the highest metal content in it. So what we are going to do? We are going to separate the metal from the ore in its purest form. So when we get the metal after this process of metallurgy, that metal will be in its pure state. So are you all ready, children? Let us learn what is metallurgy. Any process, it has got few important steps to learn. Now these are very important in the process of metallurgy. Let's see what are those. The first one is concentration of ore. What is concentration of ore? That is the most important basic process or basic step which involves the removal of impurities or unwanted materials. Impurities in the form of gangue, that is sand, dust, all those. So the first step is concentration of ore. You are going to remove the impurities. After removing impurities, what am I going to do? We are going to extract the metal from the concentrated ore. My ore is concentrated. Now I am going to do some extraction. What am I going to do in that? I am going to convert the metal into its oxide form. When the metal is converted into its oxide form, then its purification becomes simple. So the second step is extraction of metal from its concentrated ore. And what is the last step? Refining of metals. What is refining? Refining means already it is fine. You are going to make it more refined, that is purified state. So we are going to purify the metal away from all the impurities and any minor particles that are present and get the metal in its purest form. So now we are going to learn concentration of ore in today's class. There are 4 methods. Let us see how many methods we can see today. We might be seeing 2 or 3 methods, then we can continue in the next class. Now, when I am showing the concentration of ore, when I am explaining, definitely after explaining theoretically, you will be watching a video to understand in more detail about the concentration of ore. We are going to see about concentration of ore. I told you concentration of ore is nothing but removing the basic impurities that are present in the ore. Now when I say I am going to remove it, see, all the ores are not having the same properties, or all the impurities are not having the same property. So when we say every human is different, every child is different, similarly every metals are different. Every impurity is different. Sand will not have the same property like that of a sawdust, right? So the same thing happens. So depending on the nature of the ore and the impurity, these two things play a very important role in the metallurgy process. Depending on these two factors, what kind of impurity I have, what kind of ore I have, depending on that, we will be having 4 different methods of concentration. The first method is levigation or hydraulic washing. I repeat again, levigation or hydraulic washing. Forget about levigation. From the term hydraulic washing, we came to know something that is dealing with water and washing, right? Now what kind of impurity or what kind of ore I can use in this method of concentration is if my impurities are lighter, I repeat, if my impurities are lighter and my ore particles are heavier, ore particles being heavier and my impurities being lighter, I can use hydraulic washing. What happens here? Let us see this diagram. In this diagram you can see I have taken a container where the powdered ore will be poured from the top and it reaches like this. It is there now in my container. From the bottom I am going to spray water. You know children, what happens when we sprinkle or spray water from the bottom? By the force, what happens actually? Water pushes. So when the water pushes the ore particles, the impurities which are lighter will always float. We know, right, when I put a paper and stone, what happens? Paper floats on the water and the stone settles at the bottom. Similarly, when the water is sprayed, actually what is happening here? This is how the water is getting sprayed. So the ore is getting mixed here. The lighter impurities like sand, dust and all, they just come like this through this outlet, and my ore gets settled at the bottom. Slowly it comes down like this and then it is taken out. Understood children? So when we put the powdered ore and sprinkle water from the bottom, the water force pushes the ore upwards, my lighter impurities comes down, comes in the other way, and my heavier ore particles settle at the bottom and will get concentrated here and will be collected separately. Now example is very important. You can take gold ores, that is ores of gold, for this levitation or hydraulic washing process, because in exam they may ask you in fill in the blanks or match the following, right? Like they can give you gold and they can ask you which type of concentration of ore method is used. So whenever we study any method, we should be knowing the example also, because in science, as of science is concerned, any theory should be having an example. So with example you always learn. So I think you understood what is hydraulic washing. Now we will get into the next method, which is froth flotation. We are going to learn about froth flotation process. I told you, depending on the nature and impurity, the next method which we are going to see is froth flotation. In this, our impurities are heavier. In hydraulic washing we were discussing about impurities being lighter, but here impurities are heavier and ore particles are lighter. And we use, when we require sulfide ores, that is when there is a sulfide ore, we use this method of froth flotation. Now since my impurities are heavier, I want my impurities always settling at the bottom, right? But what happens with the ore particles? I have to separate my ore and impurity actually. So what I do is, I put a rotating paddle inside and I put my ore mixed with pine oil and water. What is the difference between oil and water? Oil and water, they do not mix with each other. So what happens when this paddle starts rotating, it will just rotate completely very fast so that the froth is developed. So when the froth develops, what happens? You get the oil which comes at the top layer. We know when I take water and put oil, we know oil will float at the top and water settle at the bottom. So this oil, when it mixing with water, the oil will collect all the ore particles, that is the metal, and it comes as froth or the top. And my ore being heavier, that is the impurity being heavier, it settles at the bottom. I repeat children, there is a rotating paddle and we are going to mix the ore with pine oil and water. So there is a froth stabilizer, because as it starts rotating, it starts developing froth. Froth means what? Foam, right? So we know when oil and water are mixed, water settle at the bottom and oil stays at the top. So if I want to remove my ore is lighter here, which will combine with the oil, stick to the oil and comes as froth. And the impurity being heavier will settle at the bottom. This process we call it as froth flotation. mainly used for sulfide ores. Okay. So now we will learn about magnetic separation. The third method which we are going to see is magnetic separation, the most easiest method, magnetic separation. So in this case it is very simple, condition is very simple, either my ore or the impurity should be magnetic in nature. So if the ore is magnetic also, I can use this method. If my impurity is magnetic also, I can use this method. Now this is used for separating iron, that is magnetite ore, and also tin stone, that is iron tungstate. It repeatedly comes in board exam, children, this question of magnetic separation. So examples are very important. Now how does this work? It's very simple. You have two wheels and you have a conveyor belt which is magnetic in nature. So you have two wheels with a conveyor belt that is magnetic in nature. From here I am going to pour my ore. What happens? The ore travels like this. When it travels like this, whichever is non-magnetic, whichever does not get attracted to the magnet, it just falls separately, because still here it is magnetic. This belt is with a powerful magnet. So from here the magnetic nature has lost, so it comes like this and gets separated. The one which is magnetic in nature will still continue like this and gets collected separately. So these we call it as magnetic and non-magnetic materials. So the most important application of magnetic separation is to remove the non-magnetic particles from the magnetic substances, and it's very highly used in iron and also in tin stone. So I hope you understood, children. Next process will go for leaching. It's a different method, children. You don't have to worry about the impurity being lighter or heavier, or whether it is magnetic or not magnetic. Here it is just based on solubility, whether it is soluble. Okay. So ore will be mixed in a suitable solution. You take some solution, you put the ore in that and you mix it. A chemical reaction starts taking place where the ore is getting dissolved in the solution. We know when I put sodium chloride in water, it dissolves and there is a reaction happening. Similarly, when my ore is dissolved in a solution, the ore gets dissolved and there is a chemical reaction happening. The whole solution I am going to filter it. When I am filtering, my insoluble impurities will be removed in the filter and I get my filtrate. From the filtrate, again a chemical reaction will be taking place to get the pure ore. We don't have much reactions to learn in leaching. So this is what the basic thing we have to know in leaching. When the ore is mixed in a solution, a chemical reaction occurs where the ore gets dissolved. After filtering, insoluble impurities are removed and the filtrate, you get the pure ore through a chemical reaction, and the best ore used for this is bauxite, that is aluminium ore. Now children, you can take page number 65, keep pencil in your hand. There is a table given, let us do that. Properties of ore in the two table, second one properties of impurities, select the method of concentration. Ore is heavier, high density, and property of impurity, low density. Which method we will use, children, for that? Tell me. Lighter ores. Yes, it is lighter impurity. It is hydraulic washing. You are correct. First one is hydraulic washing. Second one, ore is magnetic in nature, impurities are non-magnetic. So which one we will use? Yes, magnetic separation. Please write, children. Third one, lighter sulfide ores and impurities are high density, that is heavier. So we use again froth flotation. Whenever sulfide ore comes, it is only froth flotation. And the last one, aluminium ores that get dissolved in a solution, insoluble impurities. So we use this method, that is leaching. Okay. Now write a suitable method of concentration. Again a table is given, 4.3. Ore is given, you should find the method of concentration. Definite questions like this you will get Don't think teacher is always saying this is definite, this is definite. It has come in the previous exams. So please make sure that you learn this. So ore is tin stone. Which method do we use? Remember, magnetic separation for iron and tin. Next, bauxite. Which one? Yes, it is leaching. And zinc blende. Zinc blende is ZnS, which has got sulfur in it. So whenever sulfide ore is there, which method we will use? Yes, froth flotation. So let us stop for today with this. We will be learning about extraction of metals in the next class. You will be watching a video now to understand about this concentration of ores and metallurgy for the first process till concentration of ore, and then make sure that you jot down some important points whichever necessary, children, because you should always exceed the knowledge from the text. Don't depend only on the text. So have lot of exploring capacity, and then if you have doubts, don't hesitate to call me. Okay, so we will get back into the next topic in the next class. Stay home, stay safe. Thank you, children. Take care. Bye.
You must have seen many metals like gold, silver, platinum, copper, aluminium and others. Gold and silver are worn as ornaments, while copper and aluminium are used in making utensils. Have you ever wondered where we get these metals from? We cannot manufacture metals. These are extracted from the earth's crust. They may be found in native state or in combined state. Metals generally occur as inorganic compounds mixed with other materials. These compounds are called minerals. For example, the metal copper exists as copper sulfate or copper oxide in the earth's crust. So, copper sulfate and copper oxide are called minerals of copper. If the mineral has a large percentage of the metal in it, then it is called the ore of that particular metal. For example, bauxite, which contains up to 60% of aluminium, is an ore of aluminium, whereas cryolite, which contains only 13% of aluminium, is just a mineral. Ores contain major percentage of metals. The remaining percentage of the ore contains impurities. So, it is important to remove the impurities to extract the pure metal. This process of extraction of a metal from its ore by removal of impurities is called metallurgy. The extraction of a metal from its ore includes 4 major steps depending on the nature of impurities present in the ore. They are crushing and grinding of ore, concentration of ore, extraction of metal from the ore, and purification of metal. Let's look at each step in detail. Crushing and grinding is the first step in the extraction of metals. This step involves breaking up the large pieces of ore into smaller pieces and then grinding them into fine powder. This process is also known as pulverizing of ore. Concentration of the ore is the second step of the extraction process. It involves separation of earthy and rocky impurities from the pulverized ore. Concentration of ore can be done by many methods including hand picking, gravity separation or hydraulic separation, froth flotation process, magnetic separation, or leaching. Selection of a particular method depends on the nature of impurities present in the ore. In hand picking, large impurities like stones are picked out by hand and separated. For the concentration of heavy oxides of metals like lead, tin, iron, and so on, gravity separation or hydraulic separation is used. In gravity separation method, the ore is dropped over a sloping, vibrating, corrugated table. Simultaneously, a stream of water is passed through it. Due to the weight difference, the heavy ore particles settle down in grooves and lighter impurities are washed away. Froth flotation method is used when the metal is lighter than the impurity, as in the case of sulfide ores. Here, the crushed ore is first mixed with water and oil in a tank. The water is then agitated by blowing compressed air, because of which froth is formed on the top. The ore being lighter stick to the froth and can be separated later. Magnetic separation method is generally used for extraction of metals that show magnetic properties. The pulverized ore is passed through a conveyor belt. The electromagnetic wheel of the conveyor belt attracts only metal particles and they form a separate heap, while the impurities form another heap, thus separating the metal from impurities. In leaching, the powdered ore is treated with an acid, base, or a reagent such that the metal alone dissolves in it and the impurities don't. Then these impurities are filtered out. The dissolved metal is precipitated by adding suitable reagent to the solution. This method is used to extract aluminium and copper from their ores.